Hi, in this class, we are going to be solving May-June 2023 variant 1-3. The first question is, the diagram shows the graph y equals to f of x, which consists of the two straight lines AB and BC. The lines A dash B dash and A dash B dash and B dash C dash form the graph of g of x. So this is f of x, this is g of x, which is the result of applying a sequence of two transformations in either order. So f of x is transformed to g of x. State fully the two transformation, 4 marks question. You're going to state the name of the transformation and you're going to describe the transformation. So we can see an obvious difference in the size. So it's an enlargement. We can see that this is twice the size of this. If you want to figure it out, you identify the length. This from A to B, the column vector is 1, 2. And from A dash to B dash, the column vector is 2, 2. So is it a vertical stretch or a horizontal stretch? It's a horizontal stretch. It's a horizontal stretch with a stretch factor of, it's a horizontal stretch with a stretch factor of 2. Also, we see that the graph has been displaced. Okay, so let's apply the stretch first. If I stretch it out, so, and we know it's a horizontal stretch with a stretch factor of, so the question says y is equal to g of x, which is the result of applying a sequence of two transformation in either order to y equals to f of x. We need to state fully the two transformation. Okay, so we have studied that this and this A dash B dash is twice the size of AB. So the stretch is, it's a horizontal stretch parallel to the x-axis. And then we also can see that there's a translation involved. Okay, so first let's stretch it out. The column vector was 1, 2, and this column vector was 2, 2. It's a horizontal stretch with a stretch factor of 2. So horizontal stretch with a stretch factor of 2. Now let's draw the function. Let's draw the stretch graph. This point will remain as it is. What can you say about point B? See, the column vector was 1, 2. After being stretched by a stretch factor of 2, this is going to be, the stretch is only going to be applied in the x-axis. Okay, so the coordinate of this point is 1, 1, 3. The stretch is only going to be applied in the x-axis. So only the x coordinate is going to be affected, not the y coordinate. So now the new point, the transform point for point A would be 2, 3. Okay. What about point B? The coordinates for point B is 2, 5. After horizontally stretched, this point is going to be 4, 5. Good. And point C, this is 4, 4. After being horizontally stretched with a stretch factor of 2, this point is going to be 8, 4. Good. Now, then what happens? This is the graph. It translates vertically 2 units down. Okay. This graph translates vertically 2 units down. Is there any vertical translation? Yes. With a translation of 2 units down. Is there any horizontal translation? No. So the next transformation is going to be translation by 0 minus 2. This one is a horizontal transformation. This is a vertical transformation. Now you could have done translation first, then horizontal stretch, or you can go with this order as well, in which you are stretching first and then translating. Any questions in question number 1? Okay. Moving on to question number 2. The function f is defined for x belongs to all real values. F of x is x squared minus 6x plus c, where c is a constant. It is given that f of x is greater than 2 for all the values of x. Find the set of possible values of c. Okay, how do we go about this question? We have the function, we have the range, we need to find the possible values of x for which f of x is going to be greater than 2. So simply, we need to set f of x, our function, greater than 2. So it will give you a quadratic inequality, and we are going to solve this quadratic inequality. Okay, now we need to find the set of possible values of c. How do we find that out? Any suggestions? क्या करना चाहिए? What makes you think about the discriminant? How did you come to the conclusion that you're going to apply discriminant over here? What made you realize that we should apply discriminant? See, the range is f of x greater than 2, and it's a minimum curve. So if this is your x-axis and this is or your curve, you want your curve to be greater than 2, right? If the range is greater than 2, that means that the minimum value is greater than 2. So what can you say about the discriminant? Is it going to be greater than 0, less than 0, or equal to 0? No, it's going to be less than 0. The reason the discriminant is going to be less than 0 is because this curve has a range greater than 2. That means it doesn't have any real solutions. If it doesn't have any real solution, then the discriminant will be less than 0. So b squared minus 4ac would be less than 0. Now, b squared minus 4 times a times c is less than 0. You get an inequality 36 minus 4c plus 8 less than 0. Okay, 36 plus 8 would be 44 minus 4c less than 0. 4c will be greater than 44 and c will be greater than 11. So if c is greater than, for f of x to be greater than 2, c must be greater than 11. Okay, how do I know its discriminant is less than 0? The range of this quadratic function is greater than 2. The range can only be greater than 2 if the entire quadratic function is above the x-axis. If the entire quadratic function is above the x-axis, the minimum value, this minimum value is greater than 2. Okay, so if it is above the x-axis, it's not intersecting the x-axis, which means there are no real solutions for this quadratic function. And if there are no real solution, then the discriminant is going to be less than 0. Make sense? Is it clear? Give the complete expansion of x plus 2 upon x to the power of 5. How many terms are going to be there in the expansion? 5. 6 terms. There are always one more term than the power. Let's expand this. So the first term is going to be 5c0 x to the power of 5, 2 upon x to the power of 0. 5c1 x to the power of 4, 2 upon x to the power of 1, plus 5c2 x to the power of 3, 2 upon x to the power of 2, plus 5c3 x to the power of 2, 2 upon x to the power of 2, 3, plus 5c4 x to the power of 5 minus 4, 2 upon x to the power of 4, plus 5c5 x to the power of 0, 2 upon x to the power of 5. Now simplify all these terms down. The first term is going to be x to the power of 5 plus 5c1 is this. This is going to be 10x cube. 5c2 is 10. 10 times 4 is 40x2 to the power 5 is 32 upon x to the power 5. This is the complete expansion of the bracket. Are we clear? Okay. Now, in the expansion of a plus bx square times x plus 2 upon x square to the power 5, the coefficient of x is 0 and the coefficient of 1 upon x is 80. Find the possible values of constant a and b. अब क्या करेंगे? You're going to multiply a plus bx square with the expansion of this bracket. Okay. Do you need to multiply all the terms? No. We need the coefficient of x. We know that the coefficient of x is 0. So we need a coefficient of x. We can get the coefficient of x by multiplying a with x and bx square term with 80 upon x cube. Sorry, 80 upon x. Okay. So for coefficient of x, we are going to multiply a with 40x plus bx square with 80 upon x. So we are going to get 40a plus 80b times x. And what is this coefficient equal to? Coefficient of x is equal to 0. So therefore 40a plus 80b is equal to 0. That is going to give you the first equation. Then we have coefficient of 1 upon x. How can we get coefficient of 1 upon x? We need to multiply a with the term 1 upon x and bx square with okay, because bx square times 80 upon x cube will give us 80 divided by x. Got it? So a is going to be multiplied by 80 upon x plus bx square is going to be multiplied by 80 upon x cube, which is going to give us 80a plus 80b times x. And what is the coefficient of, sorry, 1 upon x? And what's the coefficient of 1 upon x? 80. So 80a plus 80b is equals to 80. The coefficient is 80. Now what are we going to do? We are going to solve them simultaneously. You can simplify this equation by dividing both sides by 80. And you can simplify this equation by dividing both sides by 40. Okay, this is equation number 1. This is equation number 2. Solve them simultaneously. So A is equals to minus 2B, minus 2B plus B equals to 1. So B is minus 1. When B is minus 1, A is minus 2. That is the word. Minus minus plus 2. Thank you. Yeah, it's going to be plus 2. This is the working for the second part. Question before this? Yes. Let me show it to you. Done? Okay. Please note down the working for this question. All right, move on to the next one. Yes, Hasina, do you have any question? Please ask. Okay, you are referring to this question. See, since we don't know the value of C, you can, by just looking at the equation, you cannot tell whether this equation will have real roots or no real roots or equal roots. Okay, let but the range is given. So if we know the range, we can have an idea whether, see, it's a quadratic function. We know the shape. It's a parabola with a minimum value. So if this is my axis, and if the minimum value of the function, see, it's the domain is for all real values, right? So it's going to be a parabola like this. Now, we don't know its x coordinate position. We don't know the x coordinate of the turning point, but we know that the y coordinate of the turning point is 2. So it's always going to be above the x-axis. If it is above the x-axis, okay, if it is above the x-axis, will it have any real solution? No, right? It will not have any real solution. So the discriminant will be less than 0. Okay. So since the function is greater than 2, there isn't any intersection between the line y equals to 2 and our quadratic function. So if we solve them simultaneously, if we equate them, there aren't any solutions. So there aren't any solution for this quadratic equation. Hence, discriminant is less than 0. Is it clear now? Okay. Question number 4. 3 tangent square x minus 3 sine square x minus 4 equals to 0 may be expressed in this form where you have only cosine function, where a and b and c are constant to be found. So the first step is to replace these trig functions in the form of cosine. So tangent square x can be written as sine square x upon cos square x minus 3 sine square x minus 4 equal to 0. Now, if we make the denominators common, we are going to get 3 sine square x minus 3 sine square x cos square x minus 4 cos square x equals to 0. Since we want our expression only in terms of cosine function, we are going to use the identity to replace sine square x, and we can do that by 1 minus cos square x. Now simplify this. 3 minus 3 cos square x minus 3 plus 3 cos square x. Okay, if you multiply it with cos square x as well, we are going to get minus 3 cos square x plus 3 cos x to the power of 4 minus 4 cos square x equals to 0. Now simplify this. You're going to get 3 cos x to the power of 4, 7 minus 7 minus 3 minus 10 cos square x plus 3 equals to 0. This is the disguised quadratic form. Okay, so we have expressed our answer in this form, which was required. Now, in the second part, they want us to solve this equation. Solving this equation is same as solving this equation because we reduce down this equation in this form. So the solutions of this equation are the same as the solution for this equation. But the domain now is given from 0 to 180. So first we are going to figure out the values of cosine square function. This is the disguised quadratic equation. So let k be equals to cos square x. So the equation would reduce down to 3k square minus 10k plus 3 equals to 0. Solve for the two values of k. Okay. Solve for the two values of k. Let's see what we get. We get 3 and 1 upon 3. Okay, now cos square x is equals to 3 and cos square x is equals to 1 upon 3. There aren't going to be any solution for cos square x equals to 3. Okay. See, the reason is cos x is between minus 1 and 1. Cos square x ranges between 0 and 1. So there isn't any solution for cos square x to be equal to 3. So we are going to write no solution. We're just going to ignore this. The solutions are going to be from here. Now, if you take the square root on both the sides, cosine x will be equal to positive square root 1 upon 3 and cosine x will be equal to negative square root 1 upon 3. Now, in which quadrant is cosine x positive? Cosine x is positive in the first and the fourth quadrant. First and the fourth quadrant. However, the domain of the question is 0 to 180. Asina, this is the same concept that you were asking today. The domain is from 0 to 180 degree. So I just have to restrict myself till the first and the second quadrant. So I don't need this solution. Okay, I'm going to erase this. From here, I just need the angle in the first quadrant. And from here, I know cosine theta is negative in the second and the third quadrant, but I won't need any solution in the third quadrant because the domain of the question is from 0 to 180. Now the solutions are these. This is the solution and this is the solution. First, we are going to find the basic angle. The basic angle is going to be the same in both cases. Make sure your calculator is in degree mode. Take cosine inverse of 1 upon root 3. That is going to give you 54.7. So one of the value for theta is 54.7 degrees. The other value would be 180 minus 54.7. That is 125.3 degrees. Is the working clear? Okay. Question number 5. A circle has equation x minus 1 the whole thing square plus y plus 4 the whole thing square equals to 40. A line with the equation y equals to x minus 9 intersects the circle at the points A and B. Find the coordinates of the 2 points of intersection. We have the equation of a circle, we have the equation of the line, and we need to find the point of intersection. 4 marks question. We are going to solve them simultaneously. Okay, so let's solve them simultaneously. In the equation of a circle, plug in y as x minus 9. So this is x minus 1 the whole thing square plus x minus 5 the whole thing square equals to 40. All right, now expand this. X square minus x plus 1 plus x square minus 10x plus 25 equals to 40. Reduce down the equation. 2x square minus 11x sorry, this is minus 2x. So it's going to be minus 10x. No, minus 12x plus this is going to be 26 minus 40, that's negative 40. And if we simplify this by taking 2 common, the equation would be x square minus 6x minus 7 equals to 0. Now solve for the two values of x. We're going to get minus 1 and 7. When x is minus 1, what's going to be y? When x is minus 1, y is going to be minus 10. And when x is 7, y is going to be minus 2. So the 2 points are minus 1 comma minus 10 and 7 comma minus 2. That's the working for part A. Part B says find an equation of a circle with AB as a diameter. So if AB are the points on the circumference of a circle and AB is a diameter, we need to find that equation of a circle. For equation of a circle, we need two things. One is the center of the circle and the other thing is the radius. For the center, if you know AB is a diameter, then the center of the circle is just going to be the midpoint of AB. So to find the coordinates of the center, we are just going to take the midpoint of A and B. Minus 1 plus 7 upon 2 and minus 10 minus 2 upon 2. 3 minus 12 upon 2, that's minus 6. For the radius, you're going to find the distance between this point and this point, or if you're not sure about the C coordinates, you can find the distance of AB and divide that by 2. So radius is going to be half times the distance AB, and the distance AB is going to be x2 minus x1, the whole thing square, plus y2 minus y1, the whole thing square. So 64 8 square 64 minus 2 minus minus 1, that's correct. Eight square 64 and 10 minus 2 square, that's also 8, that is 64. That's 128 square root divided by 2. So in exact form, that comes out to be 4 root 2. Okay. Now, the equation of the circle would be x minus 3 the whole thing square plus y plus 6 the whole thing square equals to 4 root 2 the whole thing square. That is 32. That's the equation of a circle with center AB. Fine. All right. The diagram shows a sector OAB of a circle with center O and radius R. Angle AOB is theta radians. It is given that the length of the arc AB is 9.6 centimeter and the area of the sector OAB is 76.8 centimeter square. Find the area of the shaded region. We need to find the area of this shaded region. To find the area of the shaded region, we are just going to find the area of the sector minus the area of the triangle. So area of shaded region is going to be area of the sector minus the area of the triangle. Now, what is given in the question? Area of the sector OAB is already given. The length of the arc AB is given, okay? And we have the angle as theta. We don't have R yet, okay? But we can find that out by the area formula. What is the area of the sector equal to? Half r square theta. So if the area is 76.8, do we know the radius? No. But r into theta. What is r times theta? R times theta is the arc length. So do we have the arc length value? 9.6. So this will allow us to find the radius. So 76.8 times 2 divided by 9.6, I'm getting radius as 16. If radius is 16, then theta would be 9.6 divided by 16. That's 3 upon 5 or 0.6 radians. Okay, for this question, always change your calculator to radian mode. So theta is 0.6. Now we can easily find the area of the shaded region. We can now find the area of the triangle. Okay, so let's find the area of the triangle first. Area of the triangle OAB. Area of the triangle OAB is going to be half times the radius, which is 16 times 16 times sine of 0.6. So sine of 0.6 times 16 times 16 times 0.5, that is 72.274. So the shaded area would be area of the sector minus the area of the triangle, which is 4.53 rounded up centimeter square. Is the working clear? Good. Part B, where we need to find the perimeter of the shaded region. Now, perimeter of the shaded region will comprise of the length AB and the arc length AB. I already know the arc length AB. I just need the length AB now. How can I find the length AB? You can find the length AB by realizing that this is a isosceles triangle. This is a isosceles triangle. Okay. So this angle is going to be theta upon 2. All right. Now, and this length is half of AB. So I'm looking at a right angle triangle. where this length is the radius, this is half of theta, and this length is half of AB. The trig ratio that is going to deal with the two sides is sine. Sine of the angle is going to be equal to the opposite side divided by the hypotenuse, and the angle is theta upon 2. So sine of 0.3 is going to be half of AB divided by the radius, that is 16. Solve for AB now. So sine of 0.3 times 16 times 2. I'm getting 9.456. And the perimeter is going to be 9.6 plus 9.46, which is 19.1 centimeter. Okay. Perimeter is the length. Perimeter of the shaded region will comprise of the length AB and the arc AB. The arc AB is already given, and I need to find the length AB now. The length AB can be found by using the trig ratio. ठीक है, तो ये length AB आ गई थी. And to find the perimeter, I'm just going to add the two lengths. Okay. Now, I want you guys to attempt this question. See, the domain of the function is given as x greater than -2. So it's an open-ended range. X is greater than -2. So what we are going to do is we are going to observe how does the function behave at -2, and how does the function behave if we take a value very, very high, higher than -2. Okay. Now at -2, as your x value approaches -2, what happens to f of x? When this value of x approaches -2, the denominator will approach to a value of 0. 5 divided by a very small value will lead this fraction to be infinitely large. And 2 minus an infinitely large value will give you minus infinity. So f of x approaches a negatively infinitely large value. Now, the second part would be what happens if x approaches a value higher than -2. Let's say how much higher? It can go up to positive infinity. So when x value approaches a very, very large value, let's say an infinitely large value, adding 2 will not make any difference. It's still the denominator is an infinitely large value. 5 divided by an infinitely large value will be a value close to 0. 2 minus 0 will still be close enough to 2. So f of x is going to approach to 2. Now, if you are moving close to -2, your value is going towards negative infinity. If you are going towards positive infinity, if your x value is going towards positive infinity, the value is reaching a ceiling of 2. The highest value would be 2. So it's approaching 2. So what's going to be the range? X is lesser than 2. And it keeps on going down to infinity, negative infinity. So f of x is greater than negative infinity and less than 2. Now, instead of writing this, what do we write? F of x is simply less than 2. So the range is going to be f of x is less than 2. Is the working for 7 part A clear? Good. Now, part B says, obtain an expression for f inverse and state the domain of the inverse function. To obtain an expression for f inverse, we are going to replace f of x with y and make x the subject. in any order you want to do. Okay, many students would make the denominators common over here and work work it out like this. That's also correct. So you want to make x the subject, yx minus 2x, or what we can do is 2x minus yx equals to 1 plus 2y. If we take x common, we are going to get 2 minus y. So x would be equal to 1 plus 2y divided by 2 minus 1. So now we are going to swap the x values with the y values. So y would be equal to 1 plus 2x divided by 2 minus x. Therefore, f inverse is 1 plus 2x divided by 2 minus x. That's the inverse function expression. Now we need to write down the domain of the inverse function. Guys, the domain of the inverse function is the same as the range of f of x. What is the range of f of x in the question? F of x is less than 2. So the domain of inverse function, domain of f inverse of x, is the same as range of f of x, which is going to be x less than 2. Clear? The function g is defined by g of x equals to x plus 3 and x is greater than 0. Obtain an expression for fg of x, giving your answer in the form of ax plus b divided by cx plus d, where a, b, c, and d are integers. Okay, now we are talking about a composite function over here, fg of x. This is g followed by f. So in function f, we are going to insert function g. Function f is 2 minus 5 upon x plus 2. 2 minus 5 upon x plus 2. And in place of x, we are going to insert function g. Now let's simplify this. We get x plus 5. We want to express our answer in this form. So that's going to be 2x plus 5 upon x plus 5. That's it. Okay. All right. Question number 8. A progression as a first term a and the second term as a square upon a plus 2, where a is a positive constant. For the case where the progression is geometric and the sum to infinity is 264, find the value of a. It's a geometric progression. The first term is a and the second term is a square upon a plus 2. Now, if it's a geometric progression, we need the common ratio. Common ratio is the second term divided by the first term. Okay, that means a square upon a plus 4 times 1 upon a. So common ratio is a upon a plus 4. The first term is a. What is sum to infinity? It's a upon 1 minus r. Sum to infinity is a upon 1 minus r. The value of the sum to infinity is given in the question. The first term is a. The common ratio is a upon a plus 4. Do we have the entire equation in terms of a? इसको solve करेंगे, we are going to get the value of a. So a plus 4 minus a. Okay, now simplify the terms. A divided by 4 upon a plus 4 is same as a multiplied by a plus 4 upon 4. Now solve this further. 264 times 4, 1056 equals to a square plus 4a. Okay, this is equal to 1056. Was it a plus 4? Oh, my bad. Sorry. Let's correct this. This is a plus 2. I accidentally wrote a plus 4. It's going to affect my calculation. I'm just changing it. It's a plus 2, a plus 2, a plus 2. So that's going to be a square plus 2a, and this was a plus 2 as well, and that was 2. So 264 times 2, that's going to be 528. A square plus 2a equals to 528. Let's solve this quadratic equation. We'll be getting two values of a. What are those? One value is 22 and the second value is minus 24. Now, what was a over here? A is a positive constant. So the only correct answer would be a equals to 22. Okay. Yeah, Hasina, I've corrected it. All right. Part B may, for the case where the progression is arithmetic and a is 6, determine the least value of n required for the sum of the first n terms to be less than minus 480. So we now know that what if the progression is arithmetic and a value is 6? We need to determine the least value of n required for the sum of the first n terms to be less than minus 480. Now the sum of the first n terms is given by n upon 2, 2a plus n minus 1 times the common difference. To find the common difference, the first term is a and the second term was a squared upon a plus 2. So to find the common difference, this is what we are going to do. D is the second term, a squared upon a plus 2 minus a. And a value is taken to be 6. So 6 squared divided by 6 plus 2 minus 6. So difference comes out to be minus 3 upon 2. Okay. So coming back to this inequality, n upon 2, 2a plus n minus 1 times minus 3 upon 2 less than minus 480. Okay, now let's simplify this quadratic inequality. Multiplying 2 with minus 480 will give us minus 960. This is going to be 4a plus minus 3n plus 3 divided by 2 times n, which will give us 4an minus 3n square plus 3n less than minus 960 times 2 will be minus 1920. Okay, now let's simplify this. 3n square. We have the a value, right? A value is 6. So 3 minus 3n square plus 24n plus 3n less than minus 1920 minus 3n square plus 27n. Okay, if I take these terms, this is going to be minus 3n square plus 27n plus 1920 less than 0. Now, whenever you multiply or divide an inequality by a negative number, the sign is going to flip. So this is going to be n square plus 9n minus 640 greater than 0. It's a quadratic inequality, and we are going to be solving for the critical values of n. The critical values are going to be, so you will have to find the critical values, you will have to use the quadratic formula. Okay, it's not going to be factorized. So the quadratic formula will give you the two critical values as 21.19. Oh, by the way, we need to find the exact? No, it doesn't say that. Okay, it doesn't say for the exact, so we can go with this. Just a second. This is going to be minus 9n. Yeah, that was what I was thinking. Minus 9n. Okay, please correct this. So minus 9n. So one value of n is 30.19, and the other value of n is minus 21.19. Okay, now n cannot be negative because it represents the number of terms. So n, if you look at the quadratic inequality, if I write it down, this is going to be n minus 30.19 times n plus 21.19 greater than 0. Okay, now minus 21.19 and 30.19. That if this was just an inequality and n would not be representing any number of terms, then the solution would be this region. N is less than minus 21.19 and n is greater than n is less than minus 21.19 and n is greater than 30.19. But we know that n is representing the number of terms, so we are not going to take this. N must be greater than 30.19. So what is the least value of n? N represents the number of terms. It cannot be 30.19, or it should be a whole number, integer value. So the least value of n would be 31. It has to be greater than 30. Yeah, that's going to be 31. Okay, is it clear? Why not 30? Because n is greater than 30.19. It has to be greater than 30.19. Okay, 30 is lesser than 30.19. Okay, a curve which passes through 0, 3 has the equation y equals to f of x. It is given that the f prime of x is 1 minus 2 upon x minus 1 cube. Find the equation of the curve. We have the gradient function. We need to find the equation of the curve. We are going to integrate the function. So using this f prime of x expression, which is 1 minus 2 times x minus 1 cube, I will have to negative 3. Thank you. I will have to integrate the function. Integrating f prime of x will give me f of x. Now 1 minus integral of 1 is x. Integral of this expression would be 2 times x minus 1. You add 1 to the power divided by the new power times the differentiation of x minus 1, that's just 1, plus the constant of integration. Okay, so this becomes x plus this cancels out, x minus 1 to the power of minus 2 plus c. Now to find the value of c, we are going to use the point on the curve. When f of x is 3, x is 0. So c comes out to be 2. So if c is 2, the equation f of x is going to be x plus x minus 1 to the power of minus 2 plus 2. Okay, part B says the tangent to the curve at 0, 3 intersects the curve again at one point P. The tangent to the curve at 0, 3 intersects the curve again at one point P. So the tangent to the curve at this point is also intersecting the curve again. So we don't know how the function looks like, but बात ये कि ये जो tangent है, ठीक है, इस point पे, it intersects the curve again at another point P. So to find this point P, we'll have to solve the equation of the tangent with the equation of the curve that we formed. Okay, so yes, first we need to find the equation of the tangent. So we have f prime of x function. F prime of x is 1 minus 2 upon x minus 1 to the power of 3, right? 1 minus 2 upon x minus 1 cube. Now to find the gradient at 0, we are going to substitute x 0. So gradient comes out to be plus, this is going to be plus, I think 3 आ जाएगा. 3 इसलिए because minus 1 cube is negative 1, then that's going to be 3. So the gradient is 3 and the point is 0, 3. We can easily have the equation of the tangent. Equation of tangent would be y minus y1 equals to m x minus x1. So y equals to 3x plus 3. All right. Now we have to solve this with the equation of the curve f of x. What was f of x? F of x was x plus x minus 1 to the power of minus 2 plus 2. X plus x minus 1 to the power of minus 2 plus 2. This is x minus 1. Yeah. Okay, let's solve these two equations simultaneously. So 3x plus 3 is equals to x plus x minus 1 to the power of minus 2 plus 2. Okay, we need to show that the x coordinate of the point P satisfies this equation. तो हम ये चाहते हैं कि ये equation simplify होके इसमें आ जाए. Okay. So that's going to be 2x plus 1 equals to x minus 1 to the power of minus 2. Okay. This is 2x plus 1. F of x was 3x plus 3. और हमने इसको इक्वेट कर दिया x plus x minus 1 to the power of minus 2 plus 2 से. Now that becomes 2x, that becomes 1, and this is equals to x minus 1 to the power of minus 2. Got it till here? Now if you bring this down, it's going to be 1 upon x minus 1 square, which is then going to be multiplied by 2x plus 1, right? And then if you take 1 to the other side, that's going to be 2x plus 1 times x minus 1 square minus 1 equals to 0. This is what you were asked to show. Let's see the next part. In the first part, we just have to show that the x coordinate of P is satisfied by this equation. And for the x coordinate, we are going to equate the equation of the curve and the equation of the tangent line, which we did over here. And we solved it, we simplified it and showed this equation which we were asked to find. Now, part C says, no, that doesn't mean solve for x, okay? It just means that the x coordinate is going to be obtained by an equation that can be simplified in this form. Now, obviously, you don't know how to solve this equation yet in your syllabus, right? Because a quadratic factor being multiplied by a linear factor will give you a cubic function. And in P1, you don't know how to solve cubic function, okay? So that is why part C is general, verify that x equals to 3 upon 2 satisfies this equation, and hence find the y coordinate. Instead of asking you to solve this equation, they have already given you the x value and you just have to show that it satisfies this equation. So satisfying an equation means that this equation when you're going to plug in 3 upon 2 in place of x, it's going to result to 0. So 2 times 3 upon 2 plus 1 times 3 upon 2 minus 1 square minus 1 is equal to 0. That's 4. 3 upon 2 times minus 1, that's going to be 1 upon 2 square is going to be 1 upon 4. This cancels out and you are going to have 0 on both the sides. So yes, it satisfies. Now, hence find the y coordinate. We already have the x coordinate, which is 3 upon 2. We need to find the y coordinate. The point P lies on the curve as well as on the tangent line, right? So it's your call whether you want to substitute it in the equation of the curve or equation of the tangent line. What I'll do is I'll just, for simplicity, I'll just plug it in the equation of the tangent, which is y equals to 3x plus 3. So 3 times x plus 3. 9 upon 2 plus 3 will be 9 upon 2 is 4.5 plus 3, 7.5, 7.5. Okay. So that's the y coordinate of. All right. I want you guys to try question number 10, part A. Okay, in question number 10, the diagram shows a point A and B lying on the curve with the equation given. We are asked to find the coordinates of the maximum point on the curve. To find the maximum point coordinates, we know that this is going to be the stationary point where dy by dx is going to be 0. So I'm going to differentiate this function and set it equal to 0. Differentiation of 9x would be 9. Differentiation of this bracket would be minus 3 upon 2 times 2x plus 1 to the power of 3 upon 2 minus 1. Okay, times 2. Times 2. So this comes out to be 9 minus 3 times 2x plus 1 to the power of half. You're going to set it equal to 0 and solve for the value of x. 3 times 2x plus 1 to the power of half equals to 9. 2x plus 1 to the power of half equals to 3. You square on both the sides. 2x plus 1 would be equal to 9. X would be equal to 8 upon 2, 4. When x is 4, what's y? We're going to plug this value of x back into the original equation of the curve. 9 times 4 minus bracket 2 times 4 plus 1 to the power of 3 upon 2. 9 to the power of 3 upon 2, which is going to be 27. 36 minus 27, then 9. So the point, maximum point, is going to be 4, 9. Make sense? This was the working for part A. Part B says, verify that the line AB is normal to the curve at A. Verify that the line AB is normal to the curve at A. How can we verify that it's normal to the curve at A? We have the dy by dx expression. First, we are going to find the gradient of AB. Once we have the gradient of AB, we can do the negative reciprocal of it. So to get the gradient of the tangent line at A. Now, we are going to compare the gradient of the tangent line at A. The gradient of the tangent line at A should be the same as the gradient obtained while we are going to plug in 1.5 in the dy by dx expression. So first, let's find the gradient of AB. Gradient of AB is y2 minus y1 over x2 minus x1. So 3.5 minus 5.5 divided by 7.5 minus 1.5. 3.5 minus 5.5 divided by 7.5 minus 1.5, that's negative 1 upon 3. So the gradient of the tangent at A should be 3. So that means that we are expecting the value of dy by dx at point A to be 3. So we have dy by dx function from the first part, that is 9 minus 3 times 2x plus 1 to the power of half. 9 minus 3 times 2x plus 1 to the power of half, right? Minus, yes, over here we are going to plug in x as 1.5 because we want to find the gradient dy by dx value of the gradient of the tangent at point A. So we are going to plug in the x coordinate of point A, 1.5. So when we plug in 1.5 in place of x, what do we get? 1.5 means 3 upon 2. 4 square root of 4 is 2. 9 minus 6 is 3. Is the same? Is it the same? Okay. Then it says, hence find the area of the shaded region. Okay, how can I find the area of this shaded region? First, I'm going to integrate the curve from point A to point B, and then I can minus the area of the trapezium from it. Okay. To find the area under the curve from point A and B, I'll have to integrate the curve. Area under the curve would be integral of the function, and the function given in the question was 9x. Yeah, I'm going to copy down this question over here. Dx. Okay. Now, integral of 9x would be 9x squared upon 2 minus 2x plus 1 to the power of 3 upon 2 plus 1. That's 5 upon 2 divided by 5 upon 2 times 2. I don't need to write the constant of integration because I do have the limits. The lower limit is 1.5. The upper limit is 7.5. 1.5 and 7.5. Okay, we have already integrated, so these are the limits. Now simplify this and plug in the expression. Okay, plug in the upper limit and the lower limit, you're going to get the result. So right now I'm just going to use the calculator to solve it. So I'm getting 44.6. Now the shaded area would be this area minus the trapezium area. 44.6 minus the trapezium area, that's going to be half times sum of parallel sides. The parallel sides are 5.5, 3.5, and this width would be 7.5 minus 1.5 would be 6. This is 6. And what were the parallel sides? 5.5 and 5.5 and 3.5, yeah. Times 6. This is 27. 44.6 minus 27, that is going to be 17.6 unit squared. Okay. Asina, are we clear with the working? Do you have any question? Understood? Okay, so that's all about this paper. This paper had 10 questions. Thank you. much.